What's up, guys? It's the Ninja Engineer here. I am back today with this pretty inflammatory title to talk about a myth I've heard so many times as I've kind of hit the end of my undergrad education and started working as an actual full-time engineer. And that myth is that engineering classes are just completely useless. Those 4 years you spent taking courses, spending thousands of dollars to get this engineering degree, that was all a waste of time. You're never gonna use it anyway, and the industry is completely different. I think there's some truth to this in certain scenarios that we'll talk about throughout the course of this video, but I think blanket telling everybody that engineering classes as a whole are useless and all that matters is your experience outside the classroom, I think that's not only wrong, but can actually be pretty harmful to people early on in their careers, like myself and probably like most of you. And so, yeah, if you guys have followed the channel for a while, you know that I talk so much about getting experience outside of the classroom. What 90% of my videos are about. I'm not trying to say that courses are more important than that. What I am trying to say is that they are also important, and it's important to recognize what different aspects classes serve versus internships and other forms of full-time work. So yeah, before we get into this topic, I'm the Unhinged Engineer. I make professional development content for young STEM people like myself. I work in the aerospace and defense industry, but I also make content relevant to other fields. And in addition to that, I am vlogging my grad school journey. I'm studying computer science at night through Georgia Tech's online program while I continue to work full-time. Let's get right into why your engineering classes are not useless, but you might be if you're not careful. So, what are we gonna cover here? First of all, I'm going to talk about why this sentiment that engineering courses are useless is just total crap. It's a complete lie. It's kind of like this weird copium badge of honor thing, and I just want to dispel that myth outright. After that, I want to talk about some of the potentially really bad and difficult to get out of situations that thinking this way can really get you into, and then provide some kind of counterexamples of what we are seeking for. What are we trying to build? I'm going to talk about a moat, which you'll see what I mean by that later. And then lastly, I'm going to circle back to engineering classes as a whole. I've convinced you at this point that believing engineering classes are useless is kind of a mental barrier that you can fall into at your own peril. What are classes actually useful for, and how can I get the most of them? As many of you may be starting your degree, I'm hosting this in fall, and I know a lot of you guys might be your first semester or your first semester in the second half of your degree, which is where things really pick up. So how do you make the most of these really, really important classes and get the specific value out of them that you can as compared to internships and stuff? Okay, so why is this a load of crap? A lot of times people start telling themselves this as they leave school and get into their first job, and they're not doing the kinds of work they want. So in school, they're doing lots of math, they're doing lots of coding or CAD or whatever they got interested in towards the end of this degree. And then they get into the real world, and it's not all that. Nobody's job is always technical work, no matter how hard individual contributors might try. There are other things that people have to do. And so they start giving themselves this narrative that, oh, the courses I took in school are just completely unapplicable, and working in industry is completely different. And what I want to specify here is that there are certain jobs for which this is 100% true. And I have some examples here. Systems engineering, where you're mostly just focused on meeting requirements, planning out testing, stuff like that, like very high level administrative work, ordering parts and scheduling reviews and that kind of thing. Quality assurance, I almost fell into kind of a trap of doing a QA internship really early on in my college career, and I'll talk about why doing certain things like this could be potentially bad over the long run. And so if you don't see the theme already with these jobs, I think the common through line is Microsoft Office. Sometimes you'll see, I know on a lot of QA regs or systems engineering regs, they're asking for, you're really good with Excel, or you're really good with PowerPoint. Anything where Microsoft Office is at the forefront of your daily work, you're probably gonna be right that it's not using your engineering degree and those courses you took previously, or you were doing lots of math on chalkboard or writing lots of code, are going to be useless for these jobs. Telling people that engineering courses are useless as a whole assumes that they want these kinds of jobs. There's nothing wrong with these kinds of jobs. There's nothing bad. They're not any worse engineers than anybody else. But the point I'm trying to get at is not every job never uses engineering courses. There are lots of jobs that will make the most of the courses you took in undergrad and then grad school if you continue on to it. And I know for me, there has not been a single day, even the most administrative days where I'm sitting around in meetings all day or making PowerPoints and stuff like that. For my job, I use what I learned in school every freaking day without question. And so telling people that that's not going to be the case, especially while they're still in school, is concerning to me, because then they start to tell themselves that these courses aren't useful. They kind of check out, they don't get value out of them, and then they get funneled into these kinds of jobs, which again, if that's the kind of job you want, there's nothing wrong with that, but maybe for other people, they do want something more technical. And telling them that their technical courses are not useful is not going to get them where they want to go. It's going to get them where the people giving that advice went, which is pretty common. Now, why is this a trap? Again, for the fourth time, there's nothing wrong with these jobs. However, working them for a long time does have certain implications for your career, which again, for some people, I'm sure is completely fine, but for others might kind of push them away from the kinds of jobs they want if those jobs are more technical. And to illustrate this point, I want to talk about a moat. So a moat in business is effectively just any form of protection against entrance to the market, other competitors. Your moat is what gives you that kind of first mover advantage if you're getting into this position, or in our case, applying to these jobs before other people. So just like as a general example, I'm sure you guys are familiar with how GPU intensive the AI research industry is. OpenAI and Anthropic and Google DeepMind, one of their many moats is how many freaking GPUs they have. Because if I want to start a company to compete with them, I need millions and millions of dollars to buy all the GPUs, and I just don't have that kind of cash. Similarly, they have the best talent in the world, and that talent literally is a moat, because any talent that's working at these companies is not working at their competitor. The point I'm trying to get at here is a moat is your protection against entrance into the market and against competitors. And so as you go and you build out your career, if you want increasing amounts of job security and by extension, opportunities for new jobs, it's really important that you build this moat to protect yourself from just being replaced. You don't want to be purely replaceable. You want to be irreplaceable. Over the 4 years of your degree, you have built a moat up. You have a bachelor's degree in aerospace engineering, or in my case, I'm going to get my grad degree. That's going to be another moat. I did an additional 2 or 3 years and studied computer science at a good school. You're building up this moat that makes it harder and harder for other people to compete with you. That's the point of all this. And so if you spend 4 years building up this moat for yourself in the form of your bachelor's degree, and then don't use it, you immediately start to erode at that moat that you've built. You build up all this market differentiation against all the other talent, especially if in addition to these courses, you're doing extracurriculars like we've talked about a million times. And then if the second you get out of school, you don't use any of it, you slowly start losing that moat. Use it or lose it, okay? Again, technical roles will require you to do technical work. Otherwise, nobody would get engineering degrees. We would all just start getting jobs right out of high school. So be proud of yourself that you're building up this academic moat of deep knowledge that I have listed here, and use that over the course of your career. And know that if you go into some of these other fields that aren't going to use them as much, you can lose it. It doesn't stay around forever. And so I want to provide some examples of a moat in engineering from my industry of aerospace, just to kind of list a few and get at this concept I'm talking about. So let's talk about flight software engineering, writing the code that is actually going to go on these vehicles. I have the position of flight software engineer at the top here, and then a bunch of different skills kind of in that blue moat there that you need to know. Most flight software is written in C++, or at least a low-level language that also requires some kind of operating systems knowledge. You have to know about the dynamics of your vehicle and the sensors on board. And then for actually testing and deploying these things in a way that's being validated correctly, you have to understand some CI/CD stuff. What am I trying to get at here? Well, you build up this moat of specific talents, especially the combination of those talents, and then you kind of box out other people with different skill sets, like a regular software engineer. A regular software engineer might understand C++, operating systems, and CI/CD. They might understand that better than you. A lot of them probably do. I know that's true in my case. But if they don't understand the aerospace side, then they're not going to be able to get these jobs, because that's also required. By contrast, if somebody just studies aerospace engineering and they don't get this experience building flight software in a low-level language and validating it correctly, then they're not going to be able to compete with you either, because you have all that aerospace engineering coursework that you got alongside them, plus these other forms of software engineering knowledge that they don't have. A couple of other ones, GNC and autonomy is really, really similar, right? Maybe a little bit deeper of a knowledge of vehicle dynamics and control, with a little bit less of an emphasis on like operating systems and actual flight software. But then in addition to that, if you go the autonomy route in today's world, you also have to understand AI/ML, like Python, really understanding Python and the frameworks with it, like statistics. So a lot of these filtering algorithms are built on statistics, so you have to understand how they really work at a core level. And then at this point, right, now who are you boxing out? Well, for one, you're boxing out flight software engineers that we just talked about, because they might not have the deep knowledge in really guidance, navigation, and control systems, and or the AI/ML side that's new here. Again, just like how we boxed out regular software engineers last time, you might box out like regular ML engineers who, if they've just worked at Amazon and they understand these ML models really well, but they don't have the unique combinations required for this role, you're gonna be able to box them out. One last example here, just to kind of break away from what I do, propulsion. You accrue all of these skill sets. That's really rare. And any mechanical engineer or purely chemistry/material science person, like they're not going to have that unique combination of skills you need, like understanding all those principles in addition to how rockets actually work. Rockets are pretty complicated machines, so there's a lot of prior knowledge needed there. And then of course, there's lots of iterative design of coding up simulations and CADing models and testing those models with FEA or other toolkits. And so people who maybe even have all of this theoretical knowledge, but haven't, in addition to that, understood how to use the tools required for the job, you're gonna box them out as well. So again, the whole point of these examples here is just to illustrate for technical roles, these are very technical roles I'm listing out here, technical knowledge is required. And the more of it you accrue, the more you can box out other people who just have subsets of that knowledge that's required. Okay, so finally, how are these classes actually relevant? So I've convinced you, because I'm such a great orator, that these courses are really relevant to you, and you're gonna be using them in the future for these technical jobs, if technical jobs are something you're looking for. If non-technical jobs are what you're looking for, then feel free to click off this video, but like, comment, subscribe first. In any case, how are these classes relevant? For one, I've harped on first principles a million times here, but first principles are incredibly important because they're the building blocks that you will use to understand more complex solutions. A Kalman filter is built on many first principles of statistics. Rocket engines are built on many first principles of dynamics and thermodynamics and other things. Autonomy is built on first principles of AI/ML meshed with those other kinds of statistical things I just discussed. First principles give you the little building blocks that you need to build these complicated solutions. And yes, the people who talk about classes being useless are correct to say the building blocks are not enough to get you where you need to go to ultimately get these jobs. But in a lot of cases, if you do it right, they are enough to get you in the door, which is ultimately the first step. Problem solving. What do I mean by this? We always talk about, oh, engineers are problem solvers, but I have a more specific reasoning here. Good engineering courses, lots of engineering classes I took that did teach me things, and I do remember, taught me how to solve difficult questions with an answer at the end. And that is important. Like, that's part of the job. A lot of times you just got to run some analysis. There's an answer. You got to get the right answer and be able to prove that it's right logically. But great engineering classes and great engineering professors teach you how to answer questions with no answer. We don't know what the right answer is. And so we have to build out this big analysis or trade study, whatever you want to call it, and compile lots and lots of information to ultimately draw the right conclusion. And that skill of deep, technical, data-driven analysis is really important. And school gives you a great opportunity to do that, usually at the expense of that application of actually building stuff. That's what people complain about. People complain that school is only analysis and you don't get to build stuff, and I totally get that. And that's where 8 other videos on this channel came from. But the deep technical data-driven analysis is a really important skill that great classes will teach you. Technical communication, yes, writing papers is very boring. But if you can't communicate the results of all this work we're talking about here, if you can't communicate the complicated solutions that you're gonna build based on first principles, or the complicated problems you're gonna solve with deep technical analysis, if you can't communicate those results, they're basically useless because nobody else can act on them. So being able to communicate technically is really important. In school, sometimes it's overkill how much school forces you to communicate technically. So make use of the time, make use of the reps. And then lastly, exposure. Right? I work like on the software side. I'm very interested in algorithms and flight software and simulation and all these kinds of things. I don't like propulsion. I don't like aerodynamics. I don't care. But I'm glad I took courses in them, because otherwise, when I talk to people who are interested in those things, or more importantly, are working in those fields, like I can track what they're talking about. Otherwise, I just look at them like they have three heads. And so getting exposure to other fields is what separates good engineers from great ones. You can get exposure to these other fields, talking to other people and talking to them about their jobs, but there's few times in your life that the exposure to a vast array of fields will be as overwhelming. There'll be as much volume as there is in school, because ultimately 9 times out of 10 they're paying you to work in one specific thing, and so all the extra stuff is gravy, versus in school it's required, again, for better or worse. So make use of that exposure. It will be valuable to you later, even if you decide to specialize. Okay, what are the key takeaways from this? For one, the clickbaity title, engineering classes are not useless. If you go into them with that mindset, you will ultimately become useless yourself. And that is a very, very difficult kind of moat to swim your way out of. Don't do that. Recognize that classes are really, really useful for certain things. Practical experience is useful for certain things, and courses are useful for certain things. And make sure you maximize the ROI on the courses you take, because you're paying a lot of money for them. So get the most out of it. Technical roles require technical education. That is not a mystery. Otherwise, nobody would take these classes and nobody would use them at all, which is not true, because I know that all the technical people I know, like the examples I just provided, are using what they learned in school almost every day. So if you don't want to use what you learned in school, then look to some of the non-technical Microsoft Office jobs I talked about previously. That's completely fine, no shade. But if you are looking for technical work, your courses will be useful. Lastly, when you're going through those courses, focus on the fundamentals. Yes, there's going to be lots of noise. There's going to be lots of idiosyncrasies of how you're expected to fill out assignments or things you're expected to memorize that won't be useful later on. But the first principles that classes really stress, like technical communication and problem solving, those will be incredibly useful. So hone in on those and get the most value out of it. And I'll say, just side tangent, in my experience, focusing on that's also the best way to do well in your classes, because it forces you to actually understand the material. And that always has served me better than just trying to memorize a bunch of stuff. So really focus on those fundamentals to get the highest ROI. Just wanted to dispel a myth that I've heard so many times. I hope it was genuinely valuable to you. Pretty much every job that I've had has forced me to use things I learned in school, even if that thing I learned in school is just math. I worked in a field that's completely separate from the degree I got in college for the first couple years of my career. And even that, I still used a ton of the math classes I took. I've been really lucky to have technical roles that have forced me to use my college education. And if you want those kinds of roles too, don't tell yourself that your classes are useless. They are useful, and make sure that you get the most utility out of them that you can. Thanks a lot for watching. I'm the Unhinged Engineer. I make professional development content for young engineers like myself. Some of it's clickbaity like this, other parts are not. But overall, I think it's really helpful for people trying to navigate the STEM career space like I am, because it's pretty crazy right now. Things are changing every day. And so if you're looking for someone who's going along that journey with you, then this is definitely the channel for you. So definitely like, comment, subscribe. Thank you so much for watching, and I will see you on the next episode.